Today we're going to work on simplifying expressions, which we've been doing the last few days, but we did it with the distributive property the first day, and then the second day we used multiplying binomials, so FOIL. Today we're going to simplify expressions using exponent rules. We're going to spend a couple days on this. Today is going to be just major, just kind of get you the rules that we have to talk about. And then applying rules kind of in a simple form where there's not multiple things going on. Today, just kind of applying one of them at a time. And then tomorrow, we'll expand it a little bit and see what happens if we have multiple things going on at a time. But for today, we're just going to go over the basic rules first and then do some practice with these basic rules. Just a general question. If I have x to the fifth power. A couple things with this. This part is called the base. The piece that's being risen to the exponent is called the base. So if I have something like 3x to the fifth, the base is still just x, because that's what's being risen to the exponent. Obviously, the exponent is that power up there, in this case, fifth. But when we say something like x to the fifth, mathematically, what does that mean? How many x's do I have? 5. I've got 5 x's. So we call this expanded form. So this really means x times x times x times x times x. That's what it means by taking it to an exponent. So if we have 2 to the fourth, 2 to the fourth in expanded form is 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So if we evaluate it, 2 to the fourth is actually just 16. And you can do it on your calculators, either going 2 times 2 times 2 times 2, or there's a little caret button that we'll talk about some other point, not today, on how you can evaluate that. And again, if we just kind of start going down the line, well, hang on here. Let's go back up to this one real quick, and let's talk about this. If I was going to write this in expanded form, the 3 is not repeating 5 times. The only thing that's repeating 5 times is the x value, because that's our base that's written to an exponent. So if I was going to expand that out, that would be 3x, x, 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 x. The 3 is not being risen to a power. Only the x is. If I put 3x to the fifth and put that inside parentheses and squared it, now technically this is 3x to the fifth times 3x to the fifth. And the difference is now that power is on the outside. And we're going to talk about a little bit more about what that means in a little bit and how we can simplify it in a fast fashion here in just a few minutes. So now let's go back over to here and kind of continue down. If I do 2 to the third, it's 2 times 2 times 2, that's 8. 2 squared, 2 times 2 is 4. 2 to the first power is just 2. Does anybody remember what anything is to the 0 power? Not 0. 1. Anything to the 0 power is always going to be 1. Okay, so that's kind of our next little definition. Anything to the 0 exponent. Anything to the 0 exponent is always going to equal 1. And that's always going to be the case. So we're going to have this complicated problem, and if it's all inside parentheses and it says it's to the 0, the answer is just 1. Okay, so anything to the 0 power is equal to 1. So if we go back to this, what do you notice going down in that direction? What's happening? It's going down by half. It's going down by half, right? So what would you think 2 to the negative 1 is going to be? It's going to be 0.5, or let's write it as a fraction. It's going to be 1/2. 2 to the negative second is really going to be 1 over 2 squared, which is 1/4. And 2 to the negative third power is 1 over 2 to the third, or 1/8. So we want to be able to put a definition for what happens if we have these negative exponents. Negative exponents make a fraction. And that fraction, if you'll notice, is just created by taking whatever our base and our exponent was and putting it under 1. So if I have a to the negative third, I'm going to write that as the fraction 1 over a to the third. It becomes a fraction, and the exponent becomes positive. Those things are equivalent to each other. That's kind of what we call a negative exponent rule. Okay, we'll talk about it in a minute. So far, so good? Okay, so the next question is, how do we go about multiplying them? What happens if we multiply exponents? And these are our 3 rules. We're going to talk about the product rule, the quotient rule, and the power-to-power rule. So the product rule. Product rule would be an example if we have x squared times x to the 5th. Now, mathematically, we could expand this to x times x, that's x squared, times x times x times x times x times x. That's x to the 5th. Now, how many x's do you have? 1, 2, 3, 4, 5, 6, 7. So we have 7 x's. So our actual answer to this would be x to the 7th. Now, obviously, we don't want to put it in expanded form every single time, so we want to come up with a rule. Rule for the product rule is really pretty easy. If you're multiplying two things together that have the same base, you add the exponents. So our exponents are 2 and 5. 2 plus 5 is 7. Your base remains the same. You take it to the 7th power. That's the product rule. You add the exponents of the bases. They are simply added. So that's the product rule. Product rule says we add the exponents. The quotient rule. Quotient means to divide. So the first one we're going to look at is what happens if we have x to the 7th over x to the 5th. Well, if we think about x to the 7th over x to the 5th, again, expanded, it's 7 x's over 5 x's. Well, if you look, x divided by x is 1. So all of these x divided by x's become 1. So all we're left with is 2 x's. So the answer for this is x squared. Mathematically, mathematically to do these, you subtract. So we're going to take our base, and then we're going to go 7 minus 5. 7 minus 5 is 2. So you get x squared, which is exactly what we had before. Well, what happens if we have a to the 3rd over a to the 7th? Procedure is still the same. Procedure doesn't change. We're going to subtract the exponents if you divide. So this is going to be equal to a to the 3 minus 7. 3 minus 7 is negative 4. So a to the negative 4th. Negative exponents are not allowed. Can't have negative exponents. So remember what we just talked about with negatives. Turn it into a fraction and make the exponent positive. So Anybody see a different way to do that instead of doing all of that work? What's further to the right on the number line, 7 or 3? 7 is further to the right on the number line. So that tells me, because 7 is technically bigger than 3, that tells me that my answer is going to be on the bottom. So kind of the shortcut way to do this is you would do 1, because 3 is bigger than 7, to the A, and just do 7 minus 3. And then you get there, and you're done. Eventually, what you should be able to do is you should just be able to say, which one's bigger, top or bottom? 7's bigger than 3. How many bigger? 4 bigger. So my a to the 4th is going to be in the denominator. That's the quotient rule. The last rule we're going to talk about today is the power of a power rule. So we're going to take x squared y to the 5th, and we're going to take that to the 3rd power. So you've got powers in your bases being taken to a power outside parentheses. So again, kind of how we've been doing it is if you take this in expanded form, it's x squared y to the 5th times x squared y to the 5th times x squared y to the 5th. Now we can just follow our product rule. Product rule says that you add exponents. So we've got x to the 2 plus 2 plus 2 and y to the 5 plus 5 plus 5. Do I expect you to write all of this down? No, I do not. I expect you to be able to go right to the end of this. Okay? This is why it works. Now, I could have taken it further and said this is x times y times y times y times y times y, x, y, 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 blah, 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 blah. Okay? Mathematically, the quick way to do it, which we like better, you multiply the exponents. This is the fast version of it. You multiply the exponents. And what you need to make sure that you do is you take each of those and everything that's in there to the 3rd power. You get x to the 6th, y to the 15th. Same solution as we had before. I got nothing for you today, Rob. I got nothing for you today. So just go hang out.
Yeah, my parade space still.
Yeah.
You're add me to the class still.
Power to power rule. So we've got 3 rules now. We've got a product rule, we've got a quotient rule, and we've got a power to power rule. So next thing we're going to do is we're going to look at examples of each that are a little bit stronger, a little bit more difficult. So the first product rule example, we're going to go 5y to the 7th times 3y squared. So we got 5y to the 7th times 3y squared. Kick it.
Kick it?
Kick the bottom of it and it'll open. There you go. So we add the exponents because we're multiplying. So that's going to be y to the 9th. 7 plus 2 is 9. Coefficients is the mathematical term for numbers. You treat the numbers just like you would treat numbers. You take 5 times 3. 5 times 3 is 15. 15y to the 9th is our solution for that, and you're done. There's nothing left to do with it. You multiply the coefficients, you add the exponents when you're doing the product rule. Multiply the coefficients, add the exponents. Next example. We've got 3ab to the 3rd times 5a squared b to the 6th. You're going to follow the same rules from above. You multiply the coefficients. You add the exponents. But now there's 2 different variables. Deal with the variables separately. So 3 times 5 is 15. How many a's do I have in the first one? There's understood to be a 1 there. So we've got 3 a's. 1 plus 2 is 3. 3 plus 6 is 9. And you're done. Product rule says that you multiply the exponents. And it doesn't matter how many terms there are. There could be 2 terms, there could be 3 terms. You still follow the same rules. So this last one of the product rule we're going to look at, there are 3 different terms now, but now we've got this negative sitting in there, and we want to be able to deal with that negative. How'd the scrimmage go? Nobody got hurt bad?
Huh?
Nobody got hurt?
Jefferson went down, but he should be back in like 2 weeks.
Multiply the numbers. 3 times 2 times 2. 12? Try to go alphabetical. We've got U and U. So I'm going to put U next. If you put V next, that's okay. 1 plus 3 is 4. Now the V's. We've got 4 minus 3 is 1. Minus another 3 is negative 2. Make sure that you only have positive exponents. So remember, if you have a negative exponent, make it a fraction and make it positive. And by making a fraction, all you have to do is drop it down to the denominator. If it's in the numerator, drop it down to the denominator. What do you suppose we do if it's in the denominator? Move it to the numerator. Okay, and we'll look at an example of that in just a second. Any questions with the product rule? I know we're going a little bit longer than we normally do today. Tomorrow is essentially going to be a do of 3 problems tomorrow during the startup, and then tomorrow will mostly be a work day tomorrow. Okay? Got to get through all these fun rules. Quotient rule. Let's look at examples of the quotient rule. (10m to the 9th over 15m cubed). So you treat the numbers like you would a fraction. So we've got the fraction 10/15. That's our fraction. What goes into both 10 and 15? Well, 5. 5 goes into 10 twice and into 15 3 times. So you reduce the coefficients. Now we subtract the exponents. 9 is bigger than 3. So my number is going to go in the numerator. 9 minus 3 is 6. That's our solution, and we're done. Nothing left to do. And you're going to find that asking yourself the question, what's bigger, 9 or 3, goes in the top, and subtracting is much easier, especially when we look at the next example. Next example, we've got x squared y over x to the 5th, y to the 3rd. What's bigger, 5 or 2? 5 is bigger. So I know my x is going to go on the bottom, and I'm just going to go 5 minus 2. 5 minus 2 is 3. There's understood to be a 1 there. 3 is bigger than 1. So y is going to go on the bottom. 3 minus 1 is 2. I have to have something in the numerator, so all we put is a 1 up there. And that's our solution. Okay. Let's look at number 7. X to the 0, y to the negative 3rd over 3xy to the 0. Number-wise, can I reduce the fraction? Can't reduce the fraction, so I'm going to go 1 over 3. I've got 0 up here, and I've got 1 in the denominator. Where's there more, in the top or the bottom? On the bottom. 1 minus 0 is 1, so that's just going to be x. I've got negative 3 and 0. So what's bigger, negative 3 or 0? 0. So it's going to go on the bottom. What's 0 minus negative 3? A minus is a plus. So that's going to be a 3. Those get hard sometimes. Anytime you have those x to the zeros, y to the zeros, they get a little bit tricky and complicated. Okay. Just be careful when you're doing it. So that's the quotient rule. Last examples we're going to look at the power to power rule. We'll look at about 3 of these and we'll call it good for the day. So 5a to the 7th and all of that squared. And again, remember what this means. This means I'm going to take 5a to the 7th times 5a to the 7th. That's what it means. So when we're thinking about these, you got to make sure that you take the squared to each of the pieces. So this is going to be 5 squared because we have to take the coefficient to the outside power, and then we multiply the exponents. So 7 times 2 is 14. The biggest mistake that happens when we're doing these is you forget to take that power to the coefficient. Now, also, the other error, 5 squared is 25, not 10. Remember, it's not 5 times 2, it's 5 times itself. Okay? There's some little errors that have a tendency to happen when we're doing the power to power rule. Okay? Kind of the same thing with this one. This is a commonly missed question, no matter if you're in algebra, algebra 2, pre-calc, calc. This type of question gets missed a lot. You have to take the negative part of it to the coefficient as well. So really, what you could think about it is it's negative to the 4th, 3 to the 4th. Exponents we just multiply. 3 times 4 is 12. 4 times 1 is 4. If you have 4 negatives, is that even? If you have 4 negatives, is that positive or negative? Negative times a negative times a negative times a negative is a positive. 3 to the 4th, I think, is 81. This is 81. X to the 12th, y to the 4th. And that's your solution. You're done. Okay. Be careful with that, and that's a huge common error. Got to make sure you take that negative to the number of powers that it needs to be as well. All right, it's going to have you do number 10, and then we're going to call it a day. And as you're doing that one, I'll hand out your worksheet for the day. You can go hand them out. Something to do while you're watching Huddle.
Yes, and it is. They did something so bad to us.
Zambroda Mazeppa.
Huh?
Zambroda Mazeppa. You guys get the JV gets to play Zambroda Mazeppa.
Yeah.
A school that is roughly an eighth of the size of us.
I'm aware.
But you're playing, your section is not like Cannon Falls. You're playing like Cannon Falls. You know?
Like our section is Byron, Stewie,
That's all that really matters. Cassie, I'm sure is in there.
well, no, not her.
Right.
So there's 6 of us, right? And Tommy goes there and just kind of. It doesn't really matter during the regular season because those guys just kill everybody.
So 2 to the 3rd. 2 times 2 times 2 is 8. A to the, for now, what is it? a to the negative 12th. What's 3 times 0? Just 0, right? So the answer itself, is there any b anymore? No, the b goes away. B to the 0, so you'd really still have b to the 0 because 3 times 0 is 0. And I can't have negative exponents. So we've got an 8, a to the negative 12th. That drops down in the denominator and comes a to the 12th. B to the 0 is just 1, so you don't even need to write it. That's your solution. Okay. So you're going to work on these 3 rules today. You're going to work on the quotient rule, the product rule, and the power of power rule. Everything you have today is just going to be one-step problems. There's going to be some review questions on the back as well. So make sure you turn it over and do the ones on the back as well. As you're going along, if you have any questions, make sure you ask. Tomorrow we'll do like 4 problems during class, and then we'll give you pretty much the rest of the time tomorrow to work on this assignment as well as the one that you're going to get tomorrow.